Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to everyone. This will be our first class recorded version, the first lecture for the subject of the high voltage engineering, BEF 44903. Alright, in this session, I will introduce to every one of you on the high voltage. What is high voltage? Alright, welcome to the high voltage world. And the definitions. Okay, when we talk about the high voltage, the simplest definition and the simplest thing that you can memorize is actually high voltage is something that is related to the 1 kV or greater for the AC and 1.2 kV or greater for the DC. This is according to the IEC standard 1983. Okay, any work, any test, anything or any operation that is conducted at this voltage level is defined as the high voltage. And element of the high voltage, okay, element of the high voltage, it consists of many things, okay, various element and field, for example, engineering field, technology, science, materials, and anything that is related to the high voltage field. For example, we look for the transmission line, circuit analysis, measurement, technique, recording, testing, material, physics, chemical phenomena, natural phenomena related to the voltage level that is greater than 1 kV AC or 1.2 kV DC, right? In simplest mean 1 kV and above, anything that related to the 1 kV and above, we can classify as the high voltage. And the high voltage engineering is not limited to only the power transmission, not limited to the power generations, not just limited to the dielectric material. It can consist of many things, the combination of those, right? Anything that operated at 1 kV and above. Okay, the history of high voltage engineering it started back in 1836. Okay, 1836 by Nicholas Calland, and he tried to develop to induce the high voltage 100 kV, starting from this one, and then from there it start to further develop, further enhance with the first transformer by the Karoly Zipanowski, and engineers from Hungary. And in the UK, they start to develop even higher voltage at 132 kV, installed in 1920s, and high voltage were introduced up to 750 in 1960s. Okay, 1960s. And Malaysia only have 500 kV. Okay, so this is just a supplementary knowledge to you, and of course you can read and do a further reading on this historical overview about the high voltage. This is just a background, initial background, that the high voltage is started from 1830s. Okay, it's about nearly 200 years ago. Okay. Okay, in the early stage of the high voltage engineering, this field is not really popular to the student, and even to the engineers, and even to the scientists. And hence, in the early stage, they develop the power system equipment before the principle are fully understood. What does it mean? Okay, means that we develop a power system equipment in which we don't provide a good insulation coordinations. We develop a power system equipment that is underrated, for example, that can easily fail due to lightning strike, switching, and so on. And some of the high voltage equipment, we made it as a overrated, which of course will give a financial damage, financial costing to the manufacturer. So the balance between the underrated and overrated is still not there, because some fundamental knowledge are not fully discovered. So this the early stage, I think this is similar to any engineering practice in which we will start from the from nothing to something, from zero to hero. We will progress from time to time to further improve all the weakness, all the hiccup to be improved from time to time until from the day of the the principle been introduced, and it will be further developed from time to time until it will become matured in the technology. Okay, some are less good in electrical properties, which led to the failure, to the premature degradations, and we have the failure of the transformer, for example, just because of the lack of knowledge on the high voltage engineering. Okay, from there, from the failure, from the financial damage, from 1920s. Okay, from 1920s, researchers start to have a better understanding on the high voltage technology or high voltage principle, in which they try to overcome the failure by the introduction of a new technology, a new improved version of the material, a new a further an advanced equipment to be able to accommodate the existing need, the current need for that time, at that time. And in this modern world, for example, due to rapid development area, we or high voltage or engineers or scientists keep working on the high voltage, on the experimental work, on the investigations, measurement, monitoring to further improve, to face the current challenge, the current development, in which nowadays we become for example, a substation in the town center cannot be developed as the one that we have in the village area, in the rural area, for example. Obviously we need to go for compact substation. That is the recent challenge, and an engineer need to keep working on the high voltage technology to adopt with the current need. Okay, many research has been conducted, many professionals, agencies, bodies, and even manufacturers jump into the high voltage technology and high voltage engineering to support with the current need. Okay, and unpopular of the high voltage in the 1980s, 90s, there were a reduction of popularity in the high voltage between the scientists, engineer, and the students, and then and it regained back the popularity due to the current need of the current technology, the sustainable current technology to face with the modern world. And in this new challenge, we are going into, for example, we are going for the climate environmental control. We go green, we go for the sophisticated technology, and what most important, to adopt with the current need, the current development in the countries, in many countries. because people or engineers, engineers or scientists or student or even people around the world that are working on the high voltage engineering, it is kind of never ending technology. Means that there are always improvement from time to time, depending on the era or the current situation or the current need. So it is not always the obsolete. For example, when we talk about the high voltage, normally what happen is that what come to our mind is actually the transformers. Okay, the transformers, it is actually the fundamental device that actually step up the voltage to make voltage rating or voltage level to become a high voltage. This is the only device that we think the backbone of the high voltage engineering. And then in the early stage, people think that the high voltage is all about the transformers. Apparently that is not always right. And the project or the working on the high voltage engineering is keep coming, keep going, dependent as per current needs and current situation in modern world. So it remained popular until now. So a little bit a quick revision on the power system. Okay, we have the generation session, transmission and distribution system. Normally we'll have the high voltage from the generation to the distribution. Of course, as I mentioned before, with the help of transformer. Sorry, okay. System level of high voltage. Okay, the high voltage level can be categorized into several categories, which are the low voltage, medium voltage, high voltage, extra high voltage, and ultra high voltage. Okay, you can read. Okay, you can see here. The low voltage is the voltage level that is less than 1 kV, and we classify for the medium voltage between the 5 kV until 66 kV, and the high voltage is classified 110 kV and above, between 220 kV, extra high voltage, so on and so forth. You can and these numbers, okay, 12, 240, 415 is actually is not a magic number. It is actually the operating the common operating voltage for many countries around the world. Okay, for example, the red color 12 volt, 214, 415, 11 kV is 33 kV, 63 kV. These are the most commonly used in practice and in many countries. The rest are is not really popular with the voltage level. Okay, flow of high voltage. Okay, by looking at this one, the flow of high voltage starting from the generation station. Okay, we have the generator, and then the step up transformer to the transmission line here, and then transmission line will come to the substation, and then will go to distribution, and distribution will come to the end user. So these are the normal flow of the high voltage engineering. High voltage. So the high voltage is required in this section, from the generator to the end user. Okay, I don't read this. It's just what I just explained before, or you. Okay, what is called as the abnormal flow of the high voltage? Okay, abnormal flow means that something the interruption to the high voltage flow. Okay, what are the causes that interrupt the flow of high voltage in practice? Okay, one and most popular one is the lightning strike. Okay, example, the lightning strike to the overhead line. Okay, the strike to the lines, okay, will cause the induced voltage and current that will cause the problem of failure to the generator and the distribution side. Okay, this is and the lightning strike can also cause damage to the equipment. High voltage equipment are very expensive. especially with the transformer, fuse, and everything. These are very expensive, and when the interruption occurred, this one that will cause a serious or financial damage to the manufacturer or maybe to the user. Other example of abnormal flow is that the switching activities, improper switching or isolation. Because switching is fundamental for many for all electrical device. As simple as you switch on the laptop, you switch off the light, you switch on the aircon. These are the switching activity for the high voltage. The switching activity may cause the induced current or the induced voltage that will cause again the fault or the failure to the device. And the fault also can be can happen from the natural phenomena, like thunderstorm, or maybe from the fallen tree branch storm, for example the vibration, vandalism, and so on. These are the things that can lead to the failure, the fault of the device, the fault of the power system equipment that will lead to the failure of the to the interruption of the high voltage flow. Okay, and then we have also the power frequency and the Ferranti effect. You can read all this. The power frequency can be triggered by the heavy contaminant on the insulated surface, for example. The power frequency can be also affected by the resonance, for example, and there are many other things on the Ferranti effects that also will trigger for the interruption to the high voltage. The interruption to the high voltage means the interruption to the high voltage will trigger normally will trigger the induced voltage, induced current that will lead to the failure, that will lead to the damage of the equipment, or maybe to the injury to the human. Right? This is what we don't want in the high voltage. That's why we call it as a abnormal flow. Okay, what we do with the high voltage? Okay, what we do with the high voltage? Okay, first, manipulation of energy. Okay, of course, the high voltage is triggered from the energy, from one form of energy to another form of energy. For example, we use on the transmission line to deliver electrical power from the generation side until we can use to the end user, right? And in other application, we use the high voltage to manipulate energy for the medical, for the X-ray, for the spray printing, inductor, ignition, and many more. So we manipulate the energy from the high voltage to transform from one voltage level to another voltage level depending on the applications, and we manipulate the voltage level which allowed us to be used, allowed this technology to be used in various applications. Okay, means that the manipulation of energy. Then what people do with the high voltage again? High voltage experimental work. Okay, the scientists or engineers or technician will do some most of the measurement, monitoring, or laboratory tests, numerous laboratory tests to investigate phenomena related to the breakdown. For example, to investigate the lightning phenomena, to further improve the protection and safety, and to increase to improve the reliability of the equipment and the protection device. So we need to go for the laboratory test so that the equipment and the device is keep updated or relevant from time to time. Okay, next is nature test. Okay, scientists normally try to learn the nature phenomena such as lightning, mechanism of lightning. Okay, these can only be conducted by using the high voltage. We can only use the high voltage to understand the mechanism of lightning. For example, this is natural phenomena, all right? Like a corona. Corona is also the natural phenomena, and the only way that we can learn about the mechanism of lightning, the initiation of lightning, is by using the high voltage engineering work, right? This will lead us to further understand the concept of the natural phenomena, natural disaster, and how to prevent them to happen, and to avoid to lead to the failure. Alright, source of high voltage generation. Okay, source of high voltage generation. They can which can be categorized into two. Okay, first is actually external, and the second one is the internal. The external is the natural creation. Okay, natural creation because due to, for example, lightning. Okay, discharge activity and high electrostatic voltage by yield, by the balloon. This also can generate the high voltage. All these natural creatures and the phenomena. Okay, and the internal, the second one is by the internal approach, which is the man-made creations. Okay, man-made creation is normally by using the generator, the transformer, and the switching activity, circuit breaker, and all the laboratory equipments that use the high voltage high voltage level. So means that this source of the high voltage can be from the nature, and it can be man-made in the laboratory due to the invention of the device and equipment. Alright, types of overvoltage. Okay, we talk about the high voltage, and there are at some point or at a certain stage that can be also be defined as a overvoltage. What is overvoltage? Okay, overvoltage can be categorized into two main category, which is the power frequency. Okay, power frequency means that at a 50 or 60 hertz. Okay, this is what we call low frequency voltage level, and in these circumstances, the overvoltage will last longer. It happened in range of 10 to 500 hertz, and in the second of 0.3 second time period up to 3600 second. Okay, that is power frequency, means that the nominal frequency for standard electrical power system 50 and 60. And there is also one condition in which the overvoltage occurred in the very short period of time. That is what we classify or call as a transient. Okay, transient is the occurrence of overvoltage in a very short period of time. If you can see here, it is in microsecond and nanosecond. As contra to this one, it is about 50-60 hertz, and the frequency for this one and the time is actually 0.3 second, and in this one is a micro scale. So we can really see the difference between the power frequency and the transient. Alright, main international bodies related to the high voltage. Okay, one of the most popular one is the IEEE. This is one the most popular international body or agency that that deal with the high voltage. Institute of Electrical and Electronic Engineering, IEEE. And then we also have the IEC. IEC standard, this is very popular. International Electrotechnical Commission, IEC. Okay, this is for European. Okay, and this is for US. And we not to deny, we have many more agencies that related to this one. And this is what we call CIGRE, International Council on Large High Voltage System. This is mostly used. CIGRE is for the European regions. And we also have the International Symposium, ISH, on high voltage. And we have the Institute of Electric Engineering and Technology, IET. This is for UK. and many more. Of course, not to deny, we have also in Malaysia, SIRIM, we have Suruhanjaya Tenaga, TNB, and so on. So these are the main bodies or main agencies that dealing with the power system and high voltage technology engineering. Okay, importance of proper high voltage system in place. Okay, okay, we understand now a little bit overview about the high voltage, and now and in the later chapter we're going to learn a very specific topic on the on the component or element of the high voltage, including the insulation material, how to generate electric, how to generate high voltage, how to provide, how to measure, how to monitor, how to provide a good insulation, and all of this technology, all of this subchapter that we're going to learn later is purely to provide a good, a proper high voltage system in place. Why it is important? Why it is important is to avoid the tragedy, okay, to avoid the failure, to avoid the injury, to avoid the damage, to avoid the financial damage, and many more. For example, here the tragedy of like the failure in the US, the total failure in which in this region, due to the failure of high voltage, and the failure of the high voltage also will cause the catastrophic disaster to the substation, explosion, and this example of a total breakdown of the insulator that will cause a failure, and we can see more and more damage caused by the improper due to the failure of high voltage engineering. Okay, this is lightning. Lightning is part of the high voltage, natural disaster that is part of the high voltage technology, and it is close, and it can be catastrophic, and the failure from the lightning will cause injury to human, death, and even and of course not to deny the failure or the damage of the equipment. See, this is the example of from the storm. For example, we have the tornado, and then it just destroy all these transmission or subs or overhead line, and this also what we call a flash over, which lead to the to the burnt of the transmission of the grounding tower. All right, and for your reference, these are some selected example for your reference. You may look for to enhance or to for further understanding on this high voltage topic. All right, I will see you again in the next chapter on the dielectric materials, and in the gas and solid dielectric, and how to generate the high voltage. With that, thank you, and Assalamualaikum warahmatullahi wabarakatuh.